In 11.8, we're going to focus on spheres. And what spheres are is pretty much like a 3D shape of a circle. And so in a circle that you've learned about before, a circle is a two-dimensional figure. Normally you just see, the circle and the radius and whatever, and you think of it as flat. Think of a penny or something, with no thickness, but just like that. However, you also can have a three-dimensional circle, which is what we're really thinking of, is a sphere, because instead of just going, on this one plane and coming up with all these radiuses, you can have a center and you can go off in all sorts of directions, flat, you can go up, you can go down, you can go to the angled like that. And basically you create this infinite set of points that are all equidistant from the radius. So it's from this, or equidistant from the center, and they all have the same length, the radius. So in a sphere, you can have a diameter across the center of the sphere. Okay, we can have that, just like on a flat circle. And we can actually take a cross-section of a sphere. We can slice through like a plane, and we could take a cross-section at any level, up, at the bottom, or right across the center of the circle. Well, when we create this cross-section right across the center of the circle, what ends up happening is we end up splitting the circle into two equal halves, and we call those hemispheres, half spheres. And if we look at the face of a half sphere, when we slice it and we open it, that flat circle face is known as the great circle. And it's the great circle because it has the greatest diameter and the greatest size, right? Or the greatest, the diameter is from here to here. That's the greatest length in the entire circle. It's a chord, but it's the greatest chord. You can have chords in circles, but again, the diameter is the largest chord. And so that'll be the biggest circle you can create with a cross section. So the surface area is known as S of a sphere is 4 pi r squared. The beauty of calculating surface area and volume of spheres is you only need to know one variable. There's only one unknown. In other words, the formula is always for the surface area, it's always 4 times pi times whatever the radius is squared. So as long as you know the radius, you're done. If you know the surface area, you can find the radius. The volume is also a set formula. It's always 4/3 pi r cubed. So the r is cubed here. And again, it should make sense, right? Because when you're looking for a surface area, that's a square unit issue, so the r is squared. When you're looking for volume, it's a cubic unit thing, so the r is cubed. So again, notice there's only one unknown here, okay? 4/3 is always in the formula. Pi is always in the formula. So now it wants you to complete a table, leave the answer in terms of pi. And so it's basically asking you to kind of plug in what's given and find the unknown. So, if the diameter is 12, the radius is always 6. And I'm just going to kind of work this way. If the radius is 7, for number 2, I know the diameter is 14. If the radius is r, I know the diameter is 2r. And if the radius is 2r, I know the diameter is 4r because it's double. So I'm kind of working it like that just to get those numbers. Now, the surface area, well, I'm going to do number 1 first. So for number 1, I know that surface area, again, is 4 pi r squared. So in this case, r is 6. So it's going to be 4 times 36 pi. And that comes out to 144 pi units squared. So that's my surface area. And it says leave my answers in terms of pi. So 144 pi squared. No, not pi squared, sorry. Undo. Sorry about that. 144 pi units squared. My bad. Okay, then we go to number 2. And so number 2 is the same thing. I'm looking for surface area. And I know surface area, again, is going to be 4 pi r squared. So it's going to be 4 times pi times 7 squared. So it's going to be 4 times 49 pi, right? And 4 times 49 is going to be 196 pi units squared. So 196 pi units squared. So I'm going to just keep with 1 and 2. I'll go back and do the other ones. Let me just kind of stick 1 and 2 all the way through. If I go back to number 1 and I'm trying to now find the volume, remember that volume is 4/3 pi r cubed. So again, in this case, I know that r is 6, so 6 cubed. So it's going to be 4/3 times pi times, I believe it's 216. And then I'm going to do 4/3 times 216. I'll do that like over 1 times pi. So again, you have a calculator, which makes this very easy, but what you could do is basically multiply all your numerators. So when you go to enter into the calculator, 4 times 216 times pi all over 3 times 1 times 1 is 3. And again, since you can leave it in pi, you'll do this math first. And then whatever that answer is, it's that answer times pi. So when I do the math, I get 288, and then it's pi. So it's going to be units cubed. So my answer for this problem is going to be 288 pi units cubed. Okay, and then I go to number 2, and I do the same thing. So for number 2, again, it's going to be volume equals 4/3 pi and then 7 cubed. And again, you have a calculator, so 4/3 times, let's say, pi over 1 times 7 cubed over 1. And you can then insert all this into your calculator, leaving pi kind of out of it. So you end up getting 1,372 pi over 3, which simplifies to 457.3 pi, and it's units cubed. And so that's the answer for that one. So 457.3 pi units cubed. Now, that's, in all of these, you know, in these two examples, we were given either the diameter or the radius, which made all this easy. So I want to do something like a number 3. I'm going to do them all. You don't have to obviously watch them all or write them all, but just until you understand it. But let's try, how would we do something like number 3 if we start with a volume? Well, if we start with a volume, I'm going to write out the volume formula here, okay? And then I'm going to plug in what I know about the volume. I know it's 32. Now notice this says 3,000, and it has like, the comma's in the wrong place. So I'm going to assume this is 32, not that. I'm going to assume that this is actually 32,000. I'm not really 100% sure. It doesn't really matter in the big picture. I'm going to assume the comma, though, is in the right place, or is in the wrong place, rather. Okay, so there's my volume, and then here's the formula side, which is on this side. So obviously from this volume, I'm going to need to find the radius, right? That's the unknown I can solve for. And once I know the radius, I'll find diameter, and I'll find surface area. So let me start by, for example, I can multiply both sides by 3. Because notice if I multiply this by 3, and I multiply this by 3, okay, what's going to happen is my denominators are going to cancel out, and that's going to give me a much simpler problem to work with. So I'm going to get 32,000 pi equals 4 pi r cubed. Now I'm going to divide by 4 pi on both sides, because that's going to help me to get r isolated, right? So 32,000 divided by 4 is 8,000, and my pi's are going to cancel. So now I've got 8,000 equals r cubed. So I should be able to take the cube root of both sides, and that should give me r. So the cube root of 8,000, is 20. So I know that the radius is 20. And so now again, if I know my radius is 20, I know my diameter is 40, and I know then that I can solve for surface area, because I know surface area is 4 pi r squared, which means 4 times pi times 20 squared. It's going to be 4 times 400 pi, or 1,600 pi. And so I know my surface area is 1,600 pi units squared. And so again, it's you just have to now pick it apart, right? You have to take what's given, and you're either finding the volume or area given a radius, or you have a volume or area and you're finding the radius, okay? There's no other way around it. There's nothing else you need to look for here. So again, in number 4, this is one of those problems. You're given the surface area. So again, surface area is 4 pi r squared. And if the surface area is 12 pi, we know that 12 pi equals 4 pi r squared. If I'm solving for r, which I need to, I'm going to have to divide both sides by 4 pi. That's going to say going to leave me with 3 equals r squared. So r is going to equal the square root of 3. So if r is the square root of 3, that means the diameter is 2 times the square root of 3. And again, when I come here to do the volume, I know it's 4/3 pi r cubed. So the volume is going to be 4/3 pi times the square root of 3 cubed. Okay, so again, I come here, this math is going to be a little bit weird, 4/3 times pi over 1, and here it's going to be the square root of 3 cubed is the square root of 3 times square root of 3 is square root of 9. Square root of 9 times 3 is square root of 27. Okay, and again, I can simplify that a little bit because it's going to be, this is going to end up simplifying to 3 radical 3 over 1. And so when I do my math, I'm going to get 12 radical 3 pi over 3. And I can even simplify that to 4 radical 3 pi. And I think I could just leave it like that. Okay, I don't even really have to do the radical 3's if I didn't really want to. So I could do 4 times radical 3 times pi units cubed, and that would be my volume. So I don't really need, too much there. And then again, we get to 5 and 6, which is again more of the same type of problem. Now here they gave you a variable and they want you to compare it. I mean, basically what they did in 5 and 6 is they took the radius and they doubled it. And they really want to know, if they double the radius, how does that affect surface area and how does that affect volume? Okay, and that's really the goal there. So let's just work it out and figure out what it does. Let's work out 5. Again, the surface area is going to be 4 pi r squared. So again, if r is r, right, it's just going to be the basic formula. So the surface area is going to be 4 pi r squared, and the volume is going to be 4/3 pi r cubed. Okay, so this is just normal. Now what happens, let's try if I double it, right? So now I'm going to have, again, surface area is 4 pi r squared, and if r is 2r, then I'm going to get 4 times pi times 4r squared, and I'm going to end up with 16 pi r squared. So notice my surface area is 16 pi r squared units squared. So what happened, if I double my radius, that difference, instead of doubling it, it's going to be that squared. Okay, so the relationship here was like 1 to 2, but the relationship here is going to be 1 to 4. Okay, kind of like the proportion. And I imagine the volume is going to be have a similar relationship. So let's see. So let's try here. Let's try the volume. It's going to be 4/3 pi, and then I'm going to have 2r cubed here. So it's going to be 4/3 times pi times, and then I'm going to get 8r cubed over 1, right? And when I do my math here, I'm going to get 32r cubed pi over 3. So I'll end up with 32r cubed pi, or pi r cubed, over 3 units cubed. And notice that the top was 8 times more, okay? So what ends up happening, remember we talked about similar shapes, and we know that the relationship of the sides, whatever that is, the areas are going to have that relationship squared, okay? So if this relationship of the sides, okay, just look at it, if the sides are r to 2r, that simplifies to a half. that means the areas, the relationship of the surface area is going to be that squared, or 1/4. And the volume, like we talked about in class with similar shapes, is going to be that relationship cubed, or 1/8. So the volume of the bigger one, this one, will be 8 times the volume of the original. The area will be 4 times the original, okay? And so again, that's pretty, or the original squared anyway. But that's it. So that's kind of how that works. And again, it's just about similar shapes, really just shows you an example of it. Okay, so now we get to just some more plain examples here. So it says the number of square centimeters, so we know we're looking for area, of a sphere is the same as the number of cubic centimeters in the volume. So basically the number, right, of the volume and the surface area is the same number. Find the radius of the sphere. So they want to know when does, remember, surface area is 4 pi r squared, volume is 4/3 pi r cubed, and we want to know when would these numbers, okay, be the same. So when would 4 pi r squared equal 4/3 pi r cubed? So to solve this, I just need to solve for r now. I'm going to first multiply everything by 3 so I can get rid of that denominator. So 12 pi r squared is going to equal 4 pi r cubed. At this point, let's say I'm going to divide. Let's start by dividing 4 pi, maybe, to both sides. Let's divide 4 pi here and 4 pi here. And so we're going to get 3r squared equals r cubed. So I'm going to divide both sides by r squared. And notice here that I got 3 equals r. I know it's weird, but it works, okay? So the radius of the sphere, since this is all in centimeters, the radius is going to be 3 centimeters. So I didn't know initially how to solve this problem, but when you set it up and you make them equal to each other, you just keep solving until you can get r by itself, and that is the answer. And then the last one is more of a traditional problem that you might get, where you get this cone here, okay? So again, it says here that a solid consists of a hemisphere of radius 1 meter on top of a cone with the same radius and height. Find the volume of the solid. So again, when you get to this video, you'll have already figured out the volume of a cone and all that, right? So we've got volume of, let's do volume of the sphere first, okay? Remember, the whole sphere is 4/3 pi r cubed. So again here, the radius is 1 meter, so 1 cubed. So our volume of our entire sphere is 4/3 pi, or you can write this as 4 pi over 3 units cubed, right? In this case, it's meters, so meters cubed. So meters cubed. So I'm going to need to know the volume of a hemisphere, which is basically half of that. So half of 4 pi over 3 is going to equal 4 pi over 6, which simplifies to 2 pi over 3. So the hemisphere is this. In other words, the top of that snow cone, pretty much, is 2 pi over 3. So I've got one of my answers that I need for this problem, okay? So I've got 2 pi over 3. Now I'm going to have to add the volume of the actual cone. So the volume of a cone is, again, same formula of like I would use for a pyramid. It's going to be the area of the base times the height of the cone. So in this case, the base is a circle. So pi r squared times the height. Now, again, the radius, it's the same radius as the semicircle or the hemisphere. So it's going to be 1 squared, and the height of the cone is 5. So again, the area of the base is going to be 1 pi, and then times 5. So the volume of the cone is 5 pi meters, and it's meters cubed, sorry, meters cubed. So this is plus 5 pi meters cubed. Now, if I wanted to leave it over 3, again, this is where I know some of you with fractions, I'm going to convert 5 pi to 15 pi over 3. Why do I do that? Because it's equivalent to 5 pi, but now my denominators are the same, and I can see that my answer is 17 pi over 3 meters cubed if I wanted to leave it as a fraction. If I didn't want to leave it as a fraction, I would just do 17 divided by 3, and I would get 5.7 pi meters cubed. And again, I can always multiply by pi to get my final answer. That's it. So this is the volume of the composite shape right here. That's the big one. And that's it. So there weren't really any basic, easy problems here with the spheres, but I think you get the gist of it. You know how to solve it. You can complete a table and fill in missing pieces.